Hey everyone, welcome back to Math with Mel. Today, we're diving into one of the most powerful tools in trigonometry, the unit circle. If you've ever wondered why we use it, how it's built, or what all those fractions and square roots mean, this video will walk you through every step. By the end, you'll not only know how to draw it, you'll actually understand where it comes from. So let's start with the basics. The unit circle is just a circle with a radius of 1. That's it, nothing fancy. We center it at the origin of the coordinate plane, right where the x and the y axis cross. Because the radius is 1, every point on the circle has coordinates that fit the equation x squared plus y squared equals 1. Those coordinates, the x and y values, are what become our cosine and sine values for an angle. So when we say cosine of theta and sine of theta, what we're really talking about is the x and y positions of a point on this circle. To build the unit circle with me today, you're going to want to have 4 different colored pens. I'll let you pause this video real quick to grab some. To start, we're going to start labeling the different degree measures around the unit circle. So I'm going to start at standard position. This right here is 0 degrees. Each one of these dots represents a 15-degree increment. So this is 15 degrees. I'm going to skip this because there's no line drawn there. And I'm going to start with this one right here. This is 30 degrees. Plus 15 degrees is 45 degrees. Plus 15 degrees is 60 degrees. And we have 2 15s, so this brings us to 90 degrees. 90 degrees plus 30 is 120. 135, 150, and I'm halfway around the circle. This is 180 degrees. I'm going to add 30. This makes 210, 225, another 15 is 240, and down here gets me 270 degrees. Right here, I'm at 300. 315 and 330 degrees. I'm almost done completing the circle. This right here is 360 degrees. And that makes sense because one full rotation around the circle is 360 degrees. We started with degrees because that's something that we feel comfortable with. But in higher level math, we switched to radians. A full circle is equal to 2 pi radians, which equals 360 degrees. So we're going to start at standard position again with our new colored pen and label those angle measures. Here, we know that this is 0 radians. Now, if I go all the way around the circle, again, that was 2 pi radians. Radians make sense if we think about them as fractions. So that's what I'm going to do. I'm not going to go all the way around the circle like I did with degrees. I'm going to go like this. 2 pi radians completes one circle. What's half of that? That's going to put me here. So half of 2 pi is pi. Half of pi is 1/2 pi, and rewrite that as pi over 2. Now this is 1/2 pi, 2 halves of pi. Right here, this is 3 halves of pi, or 3 pi over 2. And if I add another half to that, 3 halves plus 1/2 is 4 halves, and 4 halves simplifies to 2 pi. The next thing I'm going to do is I'm going to figure out what this is right here. So there's 180 degrees, which is equivalent to pi. Let's think about what portion 30 is of 180. If I take 180 and divide it by 30, it's 6. So 30 is 1/6 of 180, or 1/6 of pi, because those things are equivalent. So I'm going to write that right here. Each one of these 30-degree markings, or these 30-degree angles, is 1/6 of pi. So I'm going to measure all the sixths. 1/6 plus another 6 is 2/6. 2/6 simplifies to pi over 3. 1/6, 2/6, 3/6 simplifies to pi over 2. So I have 4/6 right here, and 4/6
simplifies to 2 pi over 3. Let's go back here. 1/6 of pi, 2/6 of pi, 3/6 of pi, 4/6 of pi, 5/6 of pi, which can't be simplified. And if I add one more 6, 6/6 is equivalent to 1, so I'm here. Let's keep adding 6. 6/6 plus 1/6 is 7/6 of pi. 7/6 plus 1/6 is 8/6, and 8/6 simplifies to 4 pi over 3. 8/6 plus 1/6 is 9/6, and 9/6 simplifies to 3/2. 9/6 plus another 6 is 10/6. So if I simplify that, I get 5 pi over 3. I'm going to go back to 10/6. 10/6 plus another 6 is 11 pi over 6. And 11 pi over 6 plus another 6 is 12 pi over 6, and that simplifies to 2 pi. Now I'm going to do different fractions. So I need to think about what portion of 45 degrees goes into 180. So how many of those parts? I see that 1, 2, 3, 4 45-degree angles go into 180. So this is 1/4 of 180, or 1/4 of pi. So I'm going to write this one as pi over 4. So this is 1/4. 2/4 simplifies to pi over 2, or 1/2. So 1/4, 2/4, 3/4 of pi. 3/4 plus another 4th is 4/4, and 4/4 simplifies to 1, and that's 1 pi, and that puts us back here. Let's keep adding 4ths. 4/4 plus 1/4 is 5/4 of pi. 5/4 plus a 4th is 6/4, and that simplifies to 3 pi over 2. 6/4 plus 1/4 is 7/4 of pi. And 7/4 of pi plus another 4th is 8/4 of pi, and that puts me back at 2. Now I have all of my radians measured. Before I start labeling anything else on the unit circle, I want us to make sure we understand where these values are coming from. So we're going to come back to 2 special right triangles. What are those special right triangles? They're the 45-90 triangle, and they are also the 30-60-90 triangle. We are working with a unit circle, so both of these triangles are going to have a radius of 1 if they were in the unit circle, and the hypotenuse here is labeled 1. So what we're going to do to make sense of this is we're going to try to figure out what these lengths are in this triangle. So maybe we're going to use x for some unknown, and I'm going to use the same variable here because both of these sides are the same length because these angle measures are the same. So how are we going to figure out what this is? We have 2 unknowns, but they happen to be the same, so that helps us out. This is where we use the Pythagorean theorem. We can do x squared plus x squared equals 1 squared. Let's make some simplifications. X squared plus x squared is 2x squared, and 1 squared is equivalent to 1. I'm trying to solve for x, so I'm going to undo this multiplication of the 2 by dividing by 2 on both sides. This makes a 1. I get x squared equals 1/2. To undo the square, I'm going to take the square root of both sides. That's equivalent to x. The square root of x squared is x. And now we keep in mind that technically we get a plus minus here, but we're trying to show these side lengths, so I'm just going to look at the positive version. I get x equals, now I can put that square root up here, square root of 1, over the square root of 2. Square root of 1 is 1, and then we just are left with square root of 2 on the bottom because that's going to be an irrational number. But mathematicians don't like square roots on the bottom. So what we're going to do is we're going to rationalize the denominator by multiplying by a special number 1. That special number 1 is square root of 2 over square root of 2. You can multiply anything by the number 1. So let's simplify this. 1 times the square root of 2 is the square root of 2, and square root of 2 times the square root of 2 is 2. So both of these lengths for x are going to be square root of 2 over 2. So I'm just going to mark that right here. You're going to start seeing these things on the unit circle. The second triangle we're going to work with is the 30, 60, 90. This is how I like to remember this one. I don't like to remember rules. I like to go back to things we know, right? We know Pythagorean theorem. So I am going to pretend that there's this line right here, and I'm going to reflect this triangle over that. And what happens when I do that is I get an equilateral triangle. So this 60-degree angle is mirrored over here. Here's that 90 degrees, and this right here gets mirrored over, so this is 30. And so when I do that, I get this giant triangle, and it's an equilateral triangle, and that's something that I think we're comfortable with. So if this is an equilateral triangle with 3 60-degree angles, they're all equivalent. This is one, and this is one, and this whole thing is one right here. But I just care about this dark triangle that I have that's bolded. And so I can think to myself, well, if this whole thing is 1, this has got to be a half. The last thing I need to solve in this triangle right here is for this height. And so again, I can use the Pythagorean theorem. I'm going to use a y value here because we've been using y to represent sine values for the height. So I'm going to set up the Pythagorean theorem. 1/2 that quantity squared plus y squared equals 1 squared. This is the same thing as 1/2 times 1/2. So what I'm going to have is 1/4 plus y squared equals 1. I'm solving for that height, y, so I'm going to subtract 1/4 from both sides. I get y squared is equal to 3/4. To get y all by itself, I'm going to undo the square with a square root. So I get y equals, I can apply the square root to the top of the fraction and the bottom of the fraction. Square root of 3 is going to give me something irrational, so I'm just going to leave it as square root of 3. But I can simplify the square root of 4 and get something nice. So square root of 4 is 2. So this right here is this value, and I'll write that right over here, square root of 3 over 2. Now, these values we are going to see in the unit circle. If you look at your unit circle right now, you might see some 45-degree angles, 60 and 30, and we're going to see these numbers all over the place. Square root of 2 over 2, right? We're going to see some of that. We're going to see square root of 3 over 2, and we're going to see some 1/2. And of course, because it's a unit circle, we'll probably see that 1. So let's go and label all of our cosine values. Cosine values are x. And let's label our sine values next. Those are the y values, or the height. Okay, I've switched my pen color. Now we're going to label the x values, which are the cosine values. So we're working with coordinates. Right now, I am going to label all of the x's, or the cosine values of that given angle, and I'm going to do that in green. All right, so let's start at standard position again. I'm going to draw a parenthesis to denote the x value here. Now, x values are the base of the triangle, or this total distance, right? So let's look at a couple of these. So if I drop this right here, my radius of my circle is 1. This looks like it's almost 1. So let's look at these things as we go around and help make sense of it. Distance from center to outside, this is 1 for the x value, or the cosine value. Now the reason we're skipping this one right here is because that's not a special right triangle. 15 degrees is not special, so let's start with the 30-degree angle. Now this one right here, if you can remember the previous video clip I just showed you, this is a 30, 60, 90 triangle tipped. And so this length right here is the square root of 3 over 2. Now this triangle right here is a 45, 45, 90. So this one right here is the square root of 2 over 2. And this triangle right here, there's that 30, 60, 90. There's that short leg. It's half of this. And that makes sense. I can see that visually. This is 1 for the radius. This is half of it. So that's how I know that's correct. And then this distance right here from the y-axis, well, this is just 0. And now that I've labeled these, everything else we're using symmetry. So I use special right triangles. Now I use symmetry. Let's remember some things about quadrants. In the first quadrant, x values are positive. So all of these lengths are positive. In the second quadrant, these values for x are negative. So when I reflect these, all of these values are going to have a negative attached to them. So this right here at 2 pi over 3 is going to be negative 1/2. At 3 pi over 4, it's going to be negative square root of 2 over 2. At 5 pi over 6, it's going to be negative square root of 3 over 2. And this is the radius again, that's 1. But since I'm in the second quadrant, I'm going to call this negative 1. I'm going to continue working around my unit circle. There's symmetry happening right for the length of these. And I need to recognize that that x values are also negative in this quadrant. So this right here, using that reflection, is going to be negative square root of 3 over 2 at 7 pi over 6. At 5 pi over 4, using that symmetry, negative square root of 2 over 2. And this right here is going to be negative 1/2. What's this distance away from the y-axis here for the cosine or the x value? Again, it's 0. Working my way into the fourth quadrant, I recognize that x values are positive in that quadrant. So I'm going to reflect this over. I have positive 1/2. I have positive square root of 2 over 2. And I have positive square root of 3 over 2. When I hit 2 pi radians, I'm getting back to 1. All right, one last pen color change. I'm going to use red for this, but you can use whatever color you want. The last thing we're going to do today is add our sine values. Okay, sines are the y-coordinate or the heights of these different triangles. So let's go and add those coordinates. Now, this height right here at standard position, there is no triangle there, so we're going to have a height or a y value of 0. Moving along to the 30 degree or pi over 6 angle rotation. That is a 30, 60, 90 triangle, so this right here is 1/2. Let's look at that. This is a radius of 1. That's looking like it's halfway. My 45, 45, 90, the x value was square root of 2 over 2. The y value is also square root of 2 over 2. The 30, 60, 90 triangle right here, this is that height of square root of 3 over 2. The height to the tip of my circle is a height of 1. Again, we're just going to use what we know about the different quadrants and whether they're negative or positive now. If I know the first quadrant, I can use that knowledge to help me with everything else. So y values are positive in this quadrant. Notice that everything we see is positive. Y values are also positive in the second quadrant. So I'm going to use that reflective symmetry. I have positive square root of 3 over 2 with an angle of rotation of 2 pi over 3. At 3 pi over 4, I have square root of 2 over 2. And at 5 pi over 6, I have a height of 1/2. I don't have any height associated with this triangle that's not existing here. It's completely collapsed. I'm at 0. Let's go down to the third quadrant. So the third quadrant, it's important to remember that y values are also negative here. So let's use that symmetry. This right here, this height is going to be negative 1/2. Right here, this is going to be negative square root of 2 over 2. And this right here is going to be negative square root of 3 over 2. I'm at the bottom of the circle, so this is negative 1. It's the minimum point for my y value. Over here, let's recognize in the fourth quadrant that y values are also negative over in the fourth quadrant. So let's use that symmetry. This is negative square root of 3 over 2. This is negative square root of 2 over 2. And this right here is negative 1/2. I get back to this height, I'm at 0. So today we completed the degrees, the radians. These are both angle measures. I completed the x values, which are cosine values, and the y values, which are the sine values.